Hi, I'm JD, and what we're going to be doing today is a hypothesis test for a mean. So let me read the problem and then you can pause the video and try to do this one on your own. The mean salary of federal government employees on general schedule is $59,678. The average salary of 30 state employees who do similar work is $58,700 with a standard deviation equaling $1,500, and that's the standard deviation of the population, sigma. At significance level of 0.01, can it be concluded that state employees earn on average less than federal employees? So pause the video and see if you can try to do this one on your own. Alright, step number one is you want to state your hypothesis. So you have your null hypothesis, and then you have your alternative hypothesis. Look at what the researcher is trying to claim. Can it be concluded that state employees earn on average less than federal employees? So you have less than and you have average. Well, the less than signifies that's going to be your alternative hypothesis. Now it's less than the federal employees average, which is the $59,678. Now, less than, greater than, or not equal to are always in your alternative hypothesis. That's the researcher's claim. In your null hypothesis, in the textbook that I use when I teach, it's always equal to. Now, in some textbooks, they might have the complete opposite of this, which would be greater than or equal to. Both ways are fine. All right, step number two. Step number two would be to define your critical values. Your critical values in your critical region is always based upon your alternative hypothesis. So if you look at your alternative hypothesis, it's less than, so it's going to be left-tailed. Now, what you can do with some of these critical values, if there's, since these are z-scores, they're typically going to repeat themselves. So you can have like a little table or whatever. I'm going to look them up here on the table. And with z-scores, the area is inside, and then you got the ones and tenths in one column, and then you got the hundreds place on top. So I'm looking for a 0.01 and find the closest to 0.01. And it looks like this value right here, which is negative 0.33. Negative 2.33. So that's my critical value. Step number three would be to find my test statistic. For here, since I know what the standard deviation is, and here I use z-scores, it's going to be the z-test. The z-test is x bar minus mu over standard deviation of the population divided by the square root of n. And this is standard error. And then you plug all your values in. Your X bar here is the average of for the state employees, which is 58,700 minus your mu, which is 59,678 divided by 1,500, that's your sigma. Square root of n, your n here is the sample size, which is 30. And so that's what you have. And normally when I calculate this, since this is 2 decimal places, I usually just put it as around 2 decimal places. So plug everything into your calculator. So 58,700 minus 59,678, close parentheses, divide this whole in denominator, so I'm going to put the whole thing in parentheses. So parentheses 1,500 divided by the square root of 30. Exit out of that by pushing over, and then click on another set of parentheses, and I get negative 3.57. Now I look at if it falls within the rejection region, so step 4, making a decision. Does it fall in the rejection region? The answer is yes. So since it falls in the rejection region, that means I'm going to reject the null hypothesis. If I'm rejecting the null hypothesis, I'm rejecting this, does that mean I am supporting the claim? And the answer is yes, I am supporting the claim. So step number 5 I'll write here because I don't have enough room. Step 5 is your conclusion. There is enough evidence to support the claim that, and you restate the claim, whatever the claim is. So here, state employees earn on average less than federal employees. So that states employees earn on average running out of room, less than federal employees. And that's it.